All right, man. So we're back. How you doing, Ale?
Very good.
Great to see you,
Happy
man.
2013.
Thank you. You
New
too.
Year. Thank you. Yes. True.
And 2013 is a long year. We just started, man.
I'm gonna turn 40 this year.
Wow, you're old, man.
Old.
Nice.
Anyway.
40 is the new 20. Remember that out there.
Very good. Good.
So let's talk a little bit about, number one, sorry we were late.
Yes,
I mean, come
late.
on, we had to take a vacation.
The break, yeah. Took some time off, stayed home.
Totally.
Wrote some code.
And I want to make a quick shout out to a gentleman who keeps trying to remind us, like, when are you going to air the show?
Oh, okay.
And his name is Tom Kirby.
Okay.
Believe that's your name. But yeah, so we're here, man. And what are we going to talk about today? DirectX Starter Kit.
DirectX Starter Kit. We're going to go talk with Roberto Sonnino.
Nice.
A young new hire that we have. He worked with us, was intern with us. But, he kind of, closed down the Starter Kit, and we're adding a little bit more feature.
Excellent.
So we are going to drill down on how you use DX, right? DX and C++, perfect marriage.
Yeah.
We want to show you, how we make it easy to start up some of the things in DX for Windows 8 application.
Awesome. So, of course, DirectX is sort of a conceptual leap if you've never used it.
Yes.
Starter Kit makes things a little bit easier.
Yes. Yeah.
Great.
Thanks to C++ libraries that create abstractions for you, And a little bit of tooling underneath, for loading texture, loading models, looking at the models a little bit. F5.
Awesome. Hey, CTP, before break.
Oh, yes, the
CTP came out. How's it doing?
CTP with the compiler CTP, where we added variety templates and a couple of other C++ 11 features. It's doing well. I saw the graphs. Of course, I never remember numbers, but I saw the graph steady slope of more people downloading. Thank you very much. Sending a lot of bugs. We already fixed a lot of things. So if you try the CTP, there is a good possibility that we fix the bugs that you found, for example, in variety templates. So I'm working on trying to show you the progress we made with all this bug fixes, for example, in variadics and so on. And Stefan is working hard on finishing up the STL implementation of uniform initializer, variety templates, and so on.
Great.
So we're going to see some of that. We're going to give you a taste of that.
Rock and roll, man. So keep downloading that CTP.
Yes, yeah. Give us feedback.
Perfect. Variadic templates. So they presented some amount of problem?
Yeah.
It's a complicated thing to implement.
It's a complicated thing for a pretty seasoned code base like our front end that went through many battles.
Understood.
He's a pretty tough guy, that dude. But we finally convinced the code base to accept variety templates.
Cool. All right, this constructor is too long.
Good. Sorry.
DirectX Starter Kit. So we are with Roberto. Why don't you tell us your name and who you are, man?
So I'm Roberto Sonnino. I'm working with the C++ team. I'm a new hire. I've been here for, 3 months, maybe 4?
3 months.
And I'm having a lot of fun with C++. I never thought it was so much fun. I come from a C# XAML background, and I've been jumping in and looking from this fresh perspective of someone that's new to C++, new to DirectX, and I had a lot of trouble with these things, and now I'm trying to make it easier for everyone to start on those things. Yeah.
So now in November you released the 3D Starter Kit, and you've been doing a lot of work since then, since we're now at almost the end of January or whenever we are, and it's now to the point where you have it running on the phone and tablet, obviously full Windows and then Windows Phone 8. So I kind of want to get a sense of what you did to make that possible and what are some of the changes that are actually in your new version of this. But first of all, I wanted to ask you a little bit about, you mentioned you were new to C++, and we talked about new to C++ with Herb a lot and all the GoingNative stuff last year and the Renaissance and stuff. What was it like for you to go from a managed kind of environment with all these great libraries underneath you to this world of native coding? Like, what was the experience like? I'd like to hear that.
It was actually surprisingly easy. I had done a lot of C and basic C++ development on college, like most computer science students. But I never had worked on shipping apps or stuff that did more than a console application. So it was a big change, and I was very pleased to see that C++ evolved. It's not that stuff we study from the textbooks in the 80s anymore. So we have modern features in the language, but we also have extensions that make it so much easier to make an app easily, like quickly, And if you compare to C#, it's getting much closer in terms of productivity as well. So when you look at a Windows 8 app built with C# and C++ and XAML, the code is very, very similar. The APIs are shared, and the language is getting smarter about the differences.
Interesting.
So it's funny. I was writing my C++ code very much like my C# code, which I know is not a very well seen practice because I come from this background.
Yeah.
But the code worked, and it was good enough. And now I'm working into improving my skills to be on par with the latest features and the best practices of code.
Excellent. All right. Well, let's dive into this.
Yeah. So your question was actually pretty good. What changed since the last starter kit? Well, I can go and show you in the website that the starter kit has actually changed quite a bit. In the end here, you can see there's the version history, and every time I release a new version, I add a new line here. And the latest release version, since the video we shot here, we've been adding support for better and better support for Surface and other Windows RT devices, and also better performance for lower graphics cards. So I listed here all the things we had changed. We added animation support. That's really cool. So now you can have animation. Let me show you what that looks like. So here I have the starter kit. It's gonna run, and this starter kit is the same that you have seen before, but now the teapot in the center will be jumping. So that animation is not written in code. This animation comes from the mesh. So the designer that built the mesh added this animation. You see, now you got wiggling nose and jumping teapot, and everything else still works. So
that's pretty neat.
So yeah, now you can actually get a mesh from a designer with 3ds Max, Maya, whatever.
And the key is like you showed in the starter kit video, is that you don't have to write that animation yourself. You usually get it from a professional.
Exactly.
So,
yeah,
if you can do it, fine.
Sure. It's much easier to get an animation from an animation tool than to write code to do complex animations like moving bones in a character.
And which file is in the project system?
It's FBX.
It's the FBX
so it's the Autodesk file, and it gets converted by Visual Studio to a runtime format, and that format does support animation as well. So
great.
So that's one big thing, and all the other things are about getting it better on a low-power device. So I'm going to show here a quick demo of what the starter kit looks like in our Surface. So this is the Towers of Hanoi game that I had shown on the other video, and you can see that it runs really nicely on the Surface as well. And how did I do that? Well, you can see that, for example, there's no reflection on the table. I had to remove some effects because they are not supporting these graphic cards. Also, I removed the anti-aliasing because that was really slow on this lower power device. So you have to be aware of things that might be wasting the user's battery or might be slower in those kinds of devices. And also as a preview, this is not something we haven't shipped yet, but we'll be shipping soon. I'm going to show you what it looks like on the phone. So actually, this is something that got me really, really excited. Like, I started doing the DX starter kit thinking about Windows 8, and then shortly after, they released Windows Phone 8, and they said, now you can port this to Windows Phone. I said, this is amazing. And that was, like, got me really excited to starting this new project for the phone. Excellent. So I hope to be able to share more very soon.
So let me ask for it right off the bat, of course, when you say porting, I mean, DirectX is a C++, C++ API, right? So the porting that you did was mainly along the lines of interoperating with XAML, right? XAML on the phone versus XAML on the Surface.
Exactly.
And of course, there were probably some feature set differences between DX. So what were some of these things that you encountered when you talk about taking an app that already runs on Windows RT, for example, so Windows on ARM, and then having it run on Windows Phone 8 on ARM, obviously, with DX. So just real briefly.
Sure. Actually, the differences are very, very small, and it's something that also got me really happy that I was able to share so much code. So the first thing you have to be aware when you're thinking about these lower power devices is that you need to switch on and off some features to make it work. For example, the Surface and all the Windows RT devices, they are they use D3D feature level 9.1. So some of them are 9.3, but mostly 9.1. While most modern graphics cards, we're talking about D3D 11 or D3D even 11.1, which is the one in Windows 8. So some features like compute shaders simply don't work. They don't compile. Also, your shaders have to be smaller, so you have to be aware of that. How does that translate in the actual starter kit? Let me show you some code.
Great.
Showing code is always better, right?
Hey, man. Show code.
Show code.
is always
Yeah.
fun.
So
Talks by itself.
exactly. So here I'm showing you the starter kit code. This is the one you can get on the web. So in the last video, I had shown this effect, the DGSL effect, which is using the shader design in Visual Studio, you can compose these effects without having to learn HLSL. This is really cool. So this is something that made my work so much easier. And the shader that you get in the end is really the same that you would write by hand, or very close. But the cool thing is that you can still optimize this shader after. So you're not blocked with this designer. You can actually come here in the advanced menu and choose export. And then you can export this one as HLSL. So you can get an HLSL file containing the shader. And this is the one that we shipped in the starter kit. So if you look at the actual code, the code is not complicated. So you can actually use this as a tool to learn HLSL yourself.
Awesome.
Yeah. So, and I was talking about feature levels. The DGSL shaders are compiled to feature level 10. So because of that, they don't work on Surface or other Windows RT. They don't work on the phone because the phone is feature level 9.3. So what we implement in the starter kit, and what I think it's a good idea to do, is we exported the DGSL shader to HLSL and used the HLSL compiler in Visual Studio to compile it to 9.3. So if you look at the HLSL compiler, when I'm compiling for Windows Win32, I'm compiling on level 9.3. And if I'm compiling on ARM, it goes to level 9.1, so for Surface. So by adding the HLSL, even I made a little change here in my HLSL code in relationship to the original one, because I wanted to cut a feature that was slow. So you start from the DGSL shader, you can export that to HLSL, and then you can modify it and use it to learn, and then you can finally compile as 9.1 and have it run on the other devices.
Excellent.
That's the main difference between Win8 and all the low-powered devices, like the fast machines and the slower, lower-powered machines. Now, another thing you have to think about is the difference between the phone platform and the Windows platform, Windows RT platform. So to show that, I have another example here, which is a version of Hanoi that I've used to compile this version for the phone and for Windows RT. And I'm going to show you what's interesting is how much shared code we have between those two versions. Again, as a preview. We didn't release this one yet, but it will be out very soon. Or maybe as you're seeing this, it's maybe already out.
Who knows?
Who knows? Yeah.
We can really mess with time on going native, man.
Yeah.
Not yet.
We can talk about the future, right?
Yes. And the past.
And the past. So this is what a project that shares code between Windows 8 and Windows Phone could look like. It's not the only way, but it's one way that I found. So in this case, I have 3 projects here. Let me open here. I have 3 projects. One of them is the Windows 8 code. And this one, Hanoi 3D Phone, is the phone XAML part. And the third one is the phone C++ part. So the phone C++ part is very close to the Windows 8 part. But the interop is very different. So how did we solve this without having to copy and paste files and like have 3 copies of the files, have to manage that? So the way I implemented this here is I added a solution folder called shared, and I added all my files that are shared here in the solution folder. And I added my assets, that means my textures, my meshes, my shaders, they're all here too. And then I added those files on each of the projects as links. So this game.cpp that in the Windows 8 project is actually the same as the solution folder, and it's the same as the phone CPP project here, game.cpp.
Great.
Then you're going to ask, so how much code is the same and how much code is different? It's pretty crazy. Actually, the whole game class, it's exactly the same in the 2 platforms. The whole logic, the interop logic, everything up to the C++ frontier with XAML is exactly the same. So you have the game logic, the game base, the directory base with a little bit of like you have some hashtag ifs to choose between if-defs, to choose between the configurations.
Yep.
And you use like some if-defs, very few, and with that we're able to have the same files on both. And the game class has no if-defs at all. So your game logic is completely shared. Your assets, exactly the same.
Great.
Your meshes, etc.
Well, I mean, and that's the way it should be. I mean, C++ is actually a portable language. That's what we talk about all the time.
Yeah. And also, if you want to, the assets technically, you might want a not so defined mesh for a lower capability.
Sure. You can also
GPU,
do that.
You can also do that.
Yeah. Instead of linking to the shared folder, you can link to some specific for Windows Phone or specific for Windows RT.
Exactly.
I think since the capabilities of the Surface and RT devices and the phone are very similar, you should actually share this lower mesh between both of them and have the higher mesh only for Windows 8, for example.
Win32x64, basically.
Yeah, for Win32x64 on higher graphics cards.
Exactly.
Because we might also be talking about a netbook, we might also be talking about an older PC.
Sure.
So when I talk 9.1, it's not only the mobile devices.
And of course, let's not forget Atom devices.
Yeah,
right?
sure.
So those are also low power, low energy.
And GPU events.
Totally poor
they don't have the same levels of GPU.
But I mean, just quickly, so the moral of the story here for C++ developers is that you can take a maximum amount of code that doesn't change. Your algorithms, your physics, blah, blah, blah. Take that and move it across devices. We talk about this all the time. They're well aware of that. How much time did you spend in the UI layers writing these apps? So both of these apps support DX on XAML. Both of these platforms support that, yes?
Yeah.
All right, so the XAML is different in this case, because one is Silverlight and one isn't.
Yeah, one is C#, one is C++.
Of course, well that's understood. So your event handlers are going to be different and whatnot. So on the phone, you're using C# and XAML?
On the phone, yeah, because XAML has to be on C# on the phone.
I just want to make sure that that's clear, that we understand that. So we've talked about that before on Channel 9.
Yeah.
So you have C# and XAML communicating with C++ to do a lot of the work with DirectX.
Yeah.
What about your event handlers? Are they also in C++ on both devices?
So the way I did this, and this is like, again, it's one solution among many you might have, is that I decided to go with the full C++ solution for the Windows 8. So that one has absolutely no C#.
Great.
And all the event handlers are C++, and they communicate directly with XAML, right? On the phone, though, since I had to have this interop barrier, so what I did is I created a proxy class on the C++ side, and then the event handlers in the C# code call this proxy class, which is a ref class, which is like uses the WinRT component, the WinRT extensions to be able to be visible on C#.
Understood.
So we call this proxy class, and the proxy class called the pure native C++ code. That's one way that I found pretty interesting. I can actually show the proxy
class. Makes sense. So your event handlers are written in C++, even though you can't, directly write event handlers.
So yeah, the layer between C++ and C# is WinRT.
Good. And it's a thin layer.
Yeah, absolutely.
So yeah, if you look at the C# XAML code here, so this is the phone XAML, and actually another interesting thing, the actual XAML code was completely shared. I copy paste the code.
Oh, that's very cool.
So of course there are some differences. For example, the app bar works differently, and the name of the component, one of them is drawing surface background grid on the phone, and on Windows 8 it's a different name, and I always forget it.
It can't be the same, right?
Can't be the same.
It's
too easy.
But I have to say, kudos to the Windows Phone team for actually modifying their Silverlight-based XAML to more match what Windows XAML is. Exactly. So they're working together, they're working hard.
Yeah, so in Windows RT, we're talking about the swap chain background panel. And on the phone, we're talking about drawing surface background grid. But they work very similarly. The difference, one of them, you're going to create the swap chain on C++, and the other, in the phone, the XAML layer will create the swap chain for you and give it to you. So the proxy class has to be aware of that. And the event handlers, you ask, is a pretty nice question. So if you look at the event handlers here, they are all in C# on the phone, but they do call, they call the DTD background, which is the proxy class, with all the native event handlers.
Cool. So you're doing the hardcore computation inside of the event handler in C++.
Exactly.
So you could actually share that code.
Exactly.
Yes.
I mean, so
Actually,
this is
I
what
am
this-
sharing that code.
Beautiful, man.
Yeah, so the logic is really stays in C++. You think you solve the problem in C++ because you're close to the X, you're already thinking in C++, stay in C++.
Great.
And you need discipline a little bit, of
Yeah.
course. You have to think how you organize the problem.
Of
Yeah.
course.
And
Nothing comes.
Talking a little bit about discipline, I found it interesting about like a way to solve some interop issues is to use a pattern that abstracts the interoperation part. So how did I do that? I came back to my XAML days, my C# XAML days, and I remember the pattern MVVM, model view view model, in which you have a separation between your logic and your view through a class called the view model. So I tried to implement that in DX, and it actually works quite well
Nice.
in this C# plus XAML, C# plus DX world, right? So I actually have a C++ class here, which I call the view model. I'm very creative with names. And this class abstracts everything that's related to messages between the two parts, the view and the code. So this class is extremely simple. It only has state, so I know if it's auto-solving or not. I know the move count. And it has events when you want to show a message to the user. So I have request message dialog, and I have signal message dialog dismissed. So the C++ code say, I want a message dialog. And it's implemented differently in the both UIs, right?
Sure.
So, and then the C# and the C++ code in the UI will handle this event and show the dialog, and then we'll call the method when it's dismissed. So you can go back and update the UI, update the logic.
Great.
So that was one way that I found to interoperate between those two.
Excellent. Smart.
And also using the async extensions here, the PPL.
PPL,
Yes.
of course.
So because the message dialog is something that is inherently async. You want to show something on the UI, wait until the user presses OK, and then continue your logic. So I use in the C++ part, I use the PPL to do this async calling.
Which is great, because of course PPL runs on the phone.
Yes.
So,
Yes.
and you absolutely want to be asynchronous on Windows Phone 8 as well.
No,
Of
no
course.
burn the
Everyone's
battery.
new about, yeah.
You don't
Everything's
want to
asynchronous.
block the UI in
Never
no
block.
platforms, right?
Never block,
Easy
man.
wait. Yes.
Okay, that's great.
Yeah.
So let's talk a little bit about going forward, or actually I'd like to step back a little more. There's clearly more for us to dig into here. We have a few more minutes where we could do that.
Okay.
And to me, it's quite interesting, coming from a non-DirectX background, but being a C++ developer. Talk a little bit about the 3D starter kit and how you think that's going to make it easier for me as a C++ developer to wrap my head around DirectX. Because that's sort of the goal, right?
Yes.
Otherwise, you
that's-
wouldn't be doing this.
That's definitely the goal.
So what have you done, is my question, to make it easier for me to wrap my head around DirectX? Having not come, maybe I'm not even a graphics developer,
Yeah.
but I know how to write C++, so,
Sure. The main thing that the starter kit enables is that we enable you to use Visual Studio's tools to include assets in your game. And I think that's the core of the value that we're delivering with the starter kit. Because it's what we're doing here, we're not doing any black magic. We're not creating some big helper library with tons of code to generate meshes for you or to generate the effects for you. We don't do that. What we do is something much simpler. If you look at the starter kit code, it's actually a very thin layer, and all it does is enable you to read the meshes that are exported by the Visual Studio toolset, so that you can create a game without having to know how to create a mesh on code or how to create a shader on HLSL. You can just use the mesh designer and the shader designer in Visual Studio Pro and up, and those will enable you to create your app really quickly. Because a game is all about, a game or a graphics app is all about the assets, right? It's all about your meshes, about your textures, your sound, animation.
The animation.
Yeah.
So there is a lot of that. You need assets, contents, and you need a very quick way to make them appear correctly on the screen, right?
Yes.
Make them, move, rotate.
Absolutely.
Even if you think about, you have a normal application. I always think about this application, the weather application, right? Instead of the dull animation of the rain coming down and so on, it's icy here in Seattle. It's a new thing, right?
Yeah.
And what about the night's avatar, the lights on the glass and so on, on the ice, right?
Sure.
So you grab in, for example, that animation from your super cool designer friend, and you plug it in, and it's actually not so much more code, right?
Excellent.
Thanks to these helper libraries, this thin layer that still make you think about what you're doing without giving you a complete framework where, you know, everything is really ended for you. And,
That's awesome.
And there is a lot of space for those frameworks, right?
Exactly.
You know,
Yeah.
we're talking about
we're talking here about like also as a learning tool, because you can quickly go file new, open the starter kit. You have a cube in the screen, great. And then you ask yourself, what do I have to do to make the cube into a teapot? Well, with the starter kit, you just go edit the mesh and change it. But the main question would be, why is the cube showing in the screen? What is being called in DX for the cube to show up? And here you can quickly see, like, this line does this line does that. It's clear, it's transparent.
Let's see that. Let's see that line.
Why not? Let's see that line.
Because, you know, this is a DX episode, and to be clear, this is just mainly a 3D starter kit episode.
Exactly.
We're going to go deep into DX.
Yes.
Yeah.
Try to get Chuck Walburn and Sean Hargraves.
Yeah.
You know,
Bunch
geek
of
out with
people,
them.
Yeah.
But this is wonderful work. And so let's definitely see what that cube looks like in code, man.
Yeah, sure.
Show it to us.
So actually, the way the starter kit does is that it abstracts everything in something we call the mesh class. So what you do is when you create your game, you have, let me show you the code that loads the mesh, which is here. So we have mesh load from file. You pass the CMO file, which is compiled by the Visual Studio tools, and then you pass the graphics object, which is an object that abstracts the whole device and context into one single place. And then you pass an array called mesh models, in this case, actually a vector, where you want the models to be stored. And then if you look at this code, load from file, you can actually understand, this is, of course, a little bit complicated because it shows you how to read the file. But you can actually understand what kind of black magic it's doing and when it's reading the file. That's why we give you all the code. We're not creating a library, a package that will hide stuff from you. So if you look here, you're going to go read the file, and we show you, like, it's a file pointer. It's not black magic, right? So you go read the file, open it, load the meshes, and then for each mesh, you're going to do mesh.load. And if you go and look into that, I could go on, but the basic idea is going to read the materials, read each line from the CMO file, will detect and discover that, save that in another structure. And then
you could have used a range-based 4 there, man. Just kidding.
Yeah, I need to get my C++ 11 up to.
Yeah. But you don't have to do it just because you can do it. But anyway, I just wanted to throw that out there for fun.
Sure. And then after you load it, at some point in your app, you're probably going to want to render it. So here we have a render. And again, we make it really easy because all you have to do is call mesh.render. Or
nice.
Not dot, but arrow, because we're C++ now. So if you look at the render method, this one will go and do the DX like the DX basic stuff to render stuff on screen. So you get the device context, you're going to load up the shaders, you're going to set up the object context constants in the GPU. Then you're going to pass the constant buffer, prepare to draw, you're going to set the input layout, topology, then you're going to go each submesh and write it on the screen. And in the end, you're going to find draw indexed, where it's actually drawing here. So we're not hiding the code. And you can see it's not that much. It's something like 20 lines. But those 20 lines in one method called mesh.render is much easier to grasp for a beginner than having to understand what each line does, and they are complicated. Like you're gonna have to know what's a shader, what's a sampler, what's an input layout, what's a topology. There are so many new
concepts.
New ideas that you have to grasp to do DX. So what we're trying to do is like let you learn about those ideas on your own pace.
Great.
And for now, we create a little package render, and that works.
Awesome. Well, hey, you know what? Thank you for doing this.
Oh.
Because it's very helpful. I know I've not programmed a lot of DirectX in my life. I know Ollie's been working on a few games in his spare time.
The problem is that now, I had to stay up all night, and then, family gets mad.
Of course,
I
man.
look like shit in the morning, stuff like that. So that's the only downside of the DirectX.
Cool. Well, hey, C++ developers, they're I think as a group, very smart. And they're going to want to look into how this stuff is implemented.
Yeah.
But it's great to be able to put your feet into the pool before you dive in.
Yes.
The fact is, you can dive in by just right-clicking and looking how something's defined.
Yeah.
But thank you for making this easier for people coming to DirectX who haven't done it before. Again, you're a C++ developer. This should be really easy for you to use. And as was your case initially, if you're a C# dev, you can read this code.
Yeah.
At least the C++ CX stuff.
Yeah.
Yes.
And
So-
F12 is your friend.
Right on, man.
F12, go to definition in Visual Studio. If you don't know, how does this work? Try F12. Sometimes the code is actually there.
Beautiful. Well, thank you for coming on.
Thanks, it was great. Thank you.
And
you.
by the way, you sound like you're from Brazil.
I am.
Rock and roll.
Yeah.
Wow, Roberto's cool, man.
He's a great guy.
It's
I
great to
love
see
him.
so many young people
Yes.
cranking code.
Starting, a lot of, starting, they've been working on C++ for a while, but a lot of new, young guns, working on C++.
Excellent.
That's good. We're going to talk even with more of them coming up.
Good. And the cool thing about what he's done with the starter kit is it actually makes it easier for you to kind of wrap your head around DirectX,
Yes.
which is a pretty complicated beast.
Yes, it is. Concept counts
Yeah.
going up, so with C++, you control, and, the interoperability Windows Phone and,
Absolutely.
tablets, that was pretty nice.
That's beautiful, man. I love seeing that.
Hey, going back to C++,
Yeah.
didn't you say something about going native?
Yeah, but,
Which year,
Well, I don't know, man. 2013 is pretty long, right?
Long. Oh, okay.
And where are
Cool.
we in the
We are
spectrum?
just not even
We're
February.
here.
Getting to February.
Exactly. So last year it was February. Why does it always have to be the same month, man?
Yeah.
So
Gotcha.
yeah, I don't. I mean, there's no comment. Man.
Okay, no comment.
But yeah, going native is a wonderful idea.
Nice. Yeah. So just want to shout out feedback about the DX.
Yes.
I want to do more DX. So let us know where you want us to go, who you want us to meet. We have a few ideas who we want to invite on the show to talk.
Great.
And ask them, grill them.
Yeah, we got to go. We'll go
Interesting
deeper, man.
Yeah, deeper.
Rock
Code,
and roll.
code. Rock and roll. Thank you, man.
Cheers.